Hello and welcome to Mr. Saucedo's YouTube videos. We are talking about how new species form. Again, a lot of this seems circular, right? A lot of what we've been talking about connects to the previous topics that we've been talking about in this unit, and that's important. It's important that you know that all of these things are connected to one another. So what causes new species to form? There are a lot of things, but isolation is a primary mechanism. The more isolated your population is from other populations, the more likely you are to develop differently because you're fulfilling a different niche in your environment. Your food source might be totally different. Like it leads to new species forming because of isolation from other populations. So we have reproductive isolation, sorry, which is when members of two different populations can no longer mate successfully with one another. So again, if we're looking at, in this case, the Hawaiian Islands, they're, in the middle of the Pacific. Where did those birds come from? Well, they could have come from many sources. They could have flown there, obviously, right? That could have been a big thing. They could have been carried in some way on like a raft or on, debris. They could have gotten blown off course by a hurricane. There are a lot of possible things. But clearly there was an original founder species of birds or founder species of birds, so multiple founders, um, on the Hawaiian Islands. And eventually, over the course of successive isolation on different islands in Hawaii, you can develop into very different organisms. And so these are directly connected to one another genetically. They're very similar. It's just they can no longer mate with each other. So they're clearly different species because they can no longer mate with each other. So speciation is the rise of two or more species from an existing species. So from one that, already exists or maybe has already gone extinct, who knows? But that's what speciation is all about. Excuse me. So geographical isolation is another one, and that's a physical barrier. So it could be, something like a giant desert or giant forests that are separating the northern spotted owl from the Mexican spotted owl down here. And it can be any geographic barrier: mountains, rivers, a lake bed dries up, and now you're on separate sides of it. It can be really any feature that you can think of geographically. It could be, continental drift, right? Now your continents are so far apart, there's not going to be any interaction anymore. And so here's a really good one. The Isthmus of Panama arose about 3.5 million years ago. And so fish that are on this side versus fish that are on that side developed, separately for 3.5 million years. And so we have pork fish on both sides, but the Panamanian pork fish is on the western side of the isthmus. And the opposite side, we have just what we call pork fish, right? And so they've developed differently, and are, they probably fulfill a different niche in their environment. And so they no longer reproduce with each other because of geographic isolation. They are totally different species now. And like it says, over time, they become genetically different until a new species forms. It doesn't happen all at once. It takes a lot of time for these kinds of things to occur. Temporal isolation is where timing prevents reproduction between different species. And so you have the spring field cricket and the fall field cricket. Both of them probably could reproduce with one another, but they only appear during a certain season. So they would never interact with each other because they're only there for a season and then they die off. So climate change has really screwed up temporal isolation because it's not like they have a watch that tells them, oh yeah, it's May. It's time for me, to appear and to come out of my cocoon or something. They normally go off of, the length of the dry season. They go off of how much sunlight there is. And, if you build a structure that's blocking sunlight from reaching the ground, they're going to think it's still dark. Temporal isolation is a very interesting one. Here's another one. You've got this breed of frog, Rana aurora, that breeds January to March, and Rana boyi, which breeds in late March to May. So they don't really interact with each other, meaning they can't reproduce with each other. Also, some organisms change their activity, so they're only awake nocturnally at night, or they're diurnal and they're only awake during the day. And so we have our eastern spotted skunk and our western spotted skunk, and they have completely different timed areas when they're awake. So they would never be able to interact and reproduce with one another. Behavioral isolation is isolation that is caused by different mating behaviors, different courtship dances. It can be a lot of things. So here's a green eyed tree frog population. And what they found are that on the northern part and the southern part of Australia here, their mating calls are different. And so this little isolated bunch here has a very different mating call pitch that's very high pitched and has different little croaks. And so if they were to come into contact with another eyed tree frog, they wouldn't mate with them because they wouldn't know that they're even the same species. Probably they'd be like, "What? Like, we don't know what's making that noise. We don't know what that is." They might even fight them. Who knows, right? And so, chemical scents, maybe you develop a new chemical scent that is in fashion in your population, and any other organism in any other population around you is going to be like, "Ooh, no, I don't know what that is." Courtship dances can change, songs can change, sexual signals can change in isolated organisms, and so again, we have the eastern and western meadowlark. They look identical basically to one another, but they use different songs to attract mates. And so they're incapable of interbreeding um, because of that difference. Um, and they're slowly becoming totally and completely different species because of that. Mechanical isolation is probably a big one because it literally means the parts don't fit together anymore. So, literally, the genitalia are incompatible and don't allow for fertilization. This is extremely common in insects. They could look the same, but have totally different reproductive organs on the inside. And so, again, differences in morphology can make two species incompatible, and that is totally and completely okay. And in Pokemon, because I've been using this as as like an explanatory device for like this entire unit. You have a Alolan Vulpix and Vulpix, and so the difference is isolation, right? In the Alola region, you've got a whole bunch of differences simply because of geographical isolation.